catch up to with us. Well, good evening, everybody. This is the second meeting of the task force for the Groton Long Point Road Bridge. It looks like we have 4 members of the task force committee on here. We have Bray Rafferty from the Conservation Commission, Frank Boland from the Resiliency and Sustainability Task Force, Michael Knoll, resident of Noank, and Andre Baumgartner, town councilor. Appreciate everybody coming on tonight. Hope everybody survived the weather all right today, and we'll get started here. The first thing I want to talk about is the role of AECom. As I mentioned in my email last month, which when we had to cancel the meeting, Jim Platosh, who was with AECom, unfortunately is a business decision, I guess, by AECom was to lay him off. Jim had been with this project from the start as our go-to guy for AECom, and even before AECom, it was a firm that was called URS for that. So it was a little bit of a shock to us, but I just want to assure everybody that our contract is with AECom, and they're a large multinational firm. So I have every confidence that they will be able to continue with this project. In fact, we have 2 engineers with us tonight, John Hapowitz, who is the project engineer, and John Ives, also another engineer. And both these guys have been actually working on this project or involved in it, I guess maybe more behind the scenes than what we've seen or what I've seen, but they have been involved in this project for quite a while. So I don't think we're really going to lose anything. We're not going back and starting from square one, I guess. So I just want to make sure everybody, is aware of that. I fully expect this to, get right up to speed real quick. And John, I don't know if you want to add anything to that, John Hapowitz.
Yes, absolutely. That was a good intro there, Greg. The Jim actually, in the structure we had in the office, reported up through me. I'm the design manager for all of design out of Connecticut. So at a higher level than Jim, I was familiar with the project, and he would keep me up to speed, with the progress reports and the presentations and things. So personally, I'm up to speed, and John Ives is on board now. He was on board in the past, and he was really the guy that was led the production behind the scenes, behind Jim. So John's our structural manager, and he can get into a little bit more of his experience. Structural manager in Connecticut. He has a history of the projects. He was the one that led the type studies and has the expertise in bridge design and how difficult hydraulic situations affect bridge design. So he understands the federal local process. We understand that that's the way we're leaning towards as far as funding for the project. He's done multiple projects for the state, for other cities and towns. Understands the people over at DOT to get things to move as far as funding applications and things. So we have the right people, to transition this and keep it moving. I mean, we may have some hiccups. I'm not going to try to disguise that, just because Jim was so intimate with, personal conversations and things like that about the project. But we'll get up to speed as fast as we can. If there's something that we can't address or direct tonight on the call, we'll take notes and we'll get back to you as soon as we can. So that's our commitment to you, Greg, and the folks involved with the project.
And this is John Ives. I just want to say I have also been with this project since the beginning. I went to the interview with Jim and with Gary Nash, who's our hydraulic engineer on the project. He's now with Mylon and McGroom, but they're on board. And I, as John mentioned, I did a lot of the work behind the scenes. Although Jim was the client contact, I wrote the prior studies and prepared the figures, the estimates, the plans. So I've been with the project since the beginning, and I know it very well. So with that, I'll get into the agenda for tonight. We're going to review the FEMA flood maps, look at the hydrologic and hydraulic design criteria, look at where we are with concept plan development, and look at what the next steps are for the project. This is the FEMA flood map that is available through the link on the town's website. And you may have gotten that link from Greg. When you look at this flood map, you see the 509J, 528J, 517J. Those just reference the specific detailed FEMA maps. There's nothing special about those numbers. What's more important is what you see here on the left, this layer list. You see the FEMA flood zones. And next slide. Zoom in on those a little bit. You see FEMA zone VE, FEMA zone AE, zone, So what are these things? Primarily, this is Groton Long Point. Here's your Groton Long Point Bridge. Can you see my cursor?
Yep.
Okay. And you can see primarily we're in zone VE and zone AE. So FEMA zone VE indicates a coastal high hazard area. It's inundated during the 100-year flood and is subject to high velocity water, including waves with wave effects 3 feet or greater. So on FEMA's maps, this map elevations that are given on the maps reflect a combined influence of, we call it a still water flood elevation and wave effects. So when you look at the FEMA map and it says elevation, elevation 12, elevation 17 in these VE zones, that includes wave effects. Zone AE generally extends from that VE zone inland to the limit of the 100-year flood from coastal sources. And zone AE is also subject to wave effects, but less than 3 feet. And the mapped elevations do not include wave effects. So this is what the FEMA map looks like. Actually, this is a fermet, which is just a kind of a zoomed in portion of a FEMA map. And here's the elevations I was referring to. You see this zone VE 16 feet. That doesn't mean that the average water elevation actually comes up that high. That includes some wave effects for that zone. So this goes toward our hydrologic and hydraulic design criteria. Since we're looking at federal local bridge program funding for this project, that means we'll have to use CONDOT design criteria. So going into the CONDOT drainage manual, the design criteria is based on the size of the watershed. In this case, that's just over 4 square miles, which makes this an intermediate structure. And it has to be designed for the 100-year return period. The requirements are for the 100-year flood, which is like the still water elevation, does not include those wave effects. They're looking for 1 foot of freeboard for the roadway. Freeboard is the distance from the top of the water to the top of the roadway. And they're looking for 1 foot of underclearance for bridges. That would be from the low point on your bridge to the top of the water. This typically leads to kind of a perched condition for a bridge, where the bridge is up higher than the rest of the roadway.
So if you satisfied the 1 foot under clearance, you've got the 1 foot freeboard taken care of
Right, at the bridge.
at the bridge.
Now your roadway may dip down further on the approach. So typically you might have kind of a hump of a profile where the bridge is up higher than the rest of the roadway.
And there's no mention made, and so far you've made no mention of sea level rise.
I haven't, but that I will talk about that later on. So it's important to note that the design criteria can be waived based on economics, environmental impacts, constructability, and right-of-way impacts, which are going to come into play here.
There you are. Thank you.
Looking at the latest flood insurance study, the 100-year still water elevation is at elevation 9.7 at the bridge. That would be your control for freeboard and for underclearance. Wave height is over 7 feet, and peak wave period just over 5 seconds. Those come into play for the causeway riprap protection. They don't affect the bridge design, the clearances. The recommended sea level rise from the Connecticut Institute of Resilience and Climate Adaptation is 20 inches by 2050. And so they have kind of a graph of projections. There are some that are conservative and then more and more unconservative. The end result is this is their recommendation, 20 inches by 2050.
That's a state, isn't that a state requirement now, John?
It's a requirement to consider sea level rise. Yes.
No, I thought it was, well, we can talk about what requirement. It's my understanding that the state of Connecticut requires designs to accommodate 20 inches of sea level rise by 2050.
Yes, there is an act.
By law, I think, or an act, whatever.
Yes, there is an act, yes.
And are all the elevations NAVD 88?
Yes. These are NAVD 88.
Thank you.
Welcome. Okay, going into our concept plan development. As Greg mentioned, this project has been around for a bit. We wrote a type study back in 2013. At that time, we considered different options for the bridge span length and the sidewalk configuration. And at that early time, it was thought that a superstructure replacement might be the best option, or because it was an economical option. And so in 2015, we followed up with a type study that kind of further developed the superstructure replacement options. But notably, a superstructure replacement, which would set the structure on the existing abutments and just replace the beams and the deck, would not meet the hydraulic criteria we were discussing. Generally, a superstructure replacement would be waived from that criteria. But it would not give you the resiliency that you are most likely looking for, because you would not be able to pick up the low chord of the structure. You would not be able to do much with the profile of the causeway. So since then, you've been working with Jim on, with this bridge task force as well as the resiliency task force. And my understanding is that you are looking to improve the resiliency of the causeway in general, and by increasing the profile grade. Now, Jim did some preliminary concept plan development, and he did that with the goal of meeting that 1 foot of underclearance at the bridge. And I just want to discuss what some of the impacts are of that. We'd be increasing the profile grade of the causeway by up to 5 feet in some locations. And there would be right-of-way impacts consisting of some significant grading onto the adjacent properties. And, obviously there will be a cost associated with that. The cost is mitigated by the federal funding through the federal local bridge program. That's cover 80% of the project cost. So taking a look at the concept plans that Jim was working on here. These are the project limits going from East Shore Ave on the west out to the beach here on the east. And I know the picture is a little small here. We did have a profile to go along with the plan view. And the upper line here, which I know it's not very legible, but the upper line here is the proposed grade. This lower horizontal line here is existing grade. And the difference between the two at the greatest difference is on the order of 5 feet. And I just want to take a quick look at the renderings because I know you've seen these in the material that Jim's presented in the past, where this is the existing bridge. And he had shown this rendering of the proposed bridge. And I just want to make it clear that these renderings were done before the profile had been advanced to incorporate the resiliency criteria. And this does not show a 5 foot increase in profile grade.
No.
So your condition with that change in grade would be much more of a perched structure. You have a much larger crest vertical curve going over the bridge here. And this is a typical bridge section from an earlier type study. It's just showing that we would be adding a sidewalk on the bridge, and that's similar to what's shown here. Now, I guess how far that sidewalk goes toward Groton Long Point is up for discussion. But it's important that you incorporate the sidewalk on the bridge because that gets the sidewalk funded through the program. Otherwise, you get a separate sidewalk bridge, as had been discussed some time ago, that would not qualify for federal funding through the program. That 80% funding. And that bridge width does increase a bit. And that helps you with the stage construction while you're trying to maintain at least alternating one-way traffic during the first stage of construction when you're removing a portion of the existing bridge, while you're maintaining traffic on the existing bridge, kind of building half of your proposed structure, shifting traffic, alternating one-way traffic onto the proposed structure, and then completing your new bridge. We had shown early on a temporary pedestrian bridge. Whether you choose to maintain pedestrian traffic through this location during construction is a town decision. I will point out that the length of the section where you're going to have alternating one-way traffic is on the order of 300 feet. So if someone is walking along that roadway with the alternating one-way traffic, it's a bit narrow not to have some type of pedestrian accommodations. Again, that's a town decision. So looking at the next steps, I think we need to make a decision about the causeway profile. Knowing what the profile implications are, and maybe we can discuss those a little bit further. But we have to decide whether we're going to try to meet the full CONDOT hydrology and hydraulic criteria, or pursue a waiver for some of the criteria. For example, you may decide that that as long as the causeway and the roadway are dry, you don't mind if the bridge is under pressure flow. The level of the water comes up above the bottom of the girders. So that type of middle ground decision would let you decrease the right-of-way impact a bit. And then and that's kind of a major decision that I think will come out of this task force committee. Once we make that decision, then we can continue with the preliminary design, land cost estimate, hydrology and hydraulic reports. And then you can move on with your referendum process and your federal local bridge program application, because you'll have a good handle on the construction costs and the coordination that's going to be required with CONDOT, specifically the hydraulics and drainage people there who you'll have to get the buy-in from if we're going to try to waive some of their criteria. And looking again at the timeline, we were looking at finishing preliminary design in 2021, and then moving on with your referendum process. And this hasn't changed. That timeline is still fine. So I just want to point that out. There's no reason on the design side for any type of delay, as long as we can make some decisions on this critical layout item. So with that, I'll open it up to discussion and any questions that anyone may have.
John, do you have the, and I don't know if you have it there or not, there's a March 17th, 2020, all the elevations, for the existing proposed bridge, proposed causeway. I think that gives kind of a good picture of what you're talking about.
It's from the last task force meeting.
I might have it if you want. I can.
I believe I have it from the last presentation.
So I have a few questions, Greg.
Yep.
I may not have heard, I'm sure I didn't hear. What's H&H?
Hydrology and hydraulics.
Oh, I should know that, right? Never heard the term. Okay.
That's what they refer to it as, so I'm trying to be consistent.
I guess at the last meeting or somewhere along the line, maybe in all the material that was circulated, there are a whole bunch of designs. And do I understand it that we've sort of cast them off? I'm not advocating for any one of them. This bridge looks fine to me. But I heard you say the sidewalk was sort of required in order to qualify for federal funding?
Sure,
Or
I'll
effective?
go back through that. The renderings Jim had presented in the last task force meeting.
Right,
We had one alternative with no sidewalk. Can you see this on my?
Yep.
Okay.
right.
Yeah.
Oh, yeah, that guy, exactly. That's the one.
With a separate pedestrian bridge. You know, a lot of times people like this boardwalk kind of look. But this isn't really showing a structure holding up the ped bridge, but there's got to be structure under here. And if you want that pedestrian bridge structure to be funded under the federal local bridge program to get that 80% funding, it has to be part of the bridge for the roadway. They will not fund a separate ped bridge.
Right.
And it's also another detractor to this alternative is that the town would have to maintain that boardwalk.
It looks like a maintenance headache to me.
It looks like a maintenance headache to me and I don't have to maintain it. I may have to pay for it, but I don't have to maintain it. And also, one thing that you want to have in this somewhere as you present this, we're talking about a design life of something around 100 years, right?
Yes.
I could be wrong. I mean,
No.
maybe you guys are looking more like,
Federal
like
criteria is at least 75 years for,
Right.
for a roadway structure. But
right.
yeah.
The old guy's been in there quite a while. So you say that, you know, it's, we're looking at something like, and 100 year of a wooden structure is iffy. That looks fine. Now, it was not clear to me. Let's go back to the one you showed me. When I looked at some of the paperwork, this road is quite a bit wider than what's there right now. Not just a small increase. I mean, it's 10 feet, 25 feet, what are 10 feet? More than that. You got a sidewalk, you got two, look like two bike lanes, and then you've got the something like 30 feet or so of roadway out there.
I can,
So it is quite a bit wider, right?
yeah, incorporating the sidewalk is the, it does cause quite an increase in the width. We're looking to bridge over the existing abutments and support the new structure behind them. You know, I think this rendering was created to, you know, convey the look from the roadway, and it doesn't really convey the support of the structure accurately. I'm going to try to go into my material here and see if I can answer your question on the width.
And if I recall correctly, when Jim presented this, he was also presenting something about the supports, and that the new bridge would require different support mechanisms, a different support structure, right?
So our intention would be to remove the existing deck and beam and cut down the abutments to an elevation we'll have to decide on, but say where you can see where the water line is on the existing abutment here.
Mhm.
That's just the tip from the typical, you know, tidal water. So that's probably your high tide line right there.
Yeah, it is.
And we'd like to cut the abutment off probably at that location, so when someone is coming through here from the marina, they can at least see the top of the existing abutments and not, not hit them with their boat. And then we'd build new abutments behind the existing structures, so we don't run into the existing foundations. So that's going to require a span length over 80 feet, somewhere between 80 and 90 feet, which you're going to be back here with the proposed abutments. So then the new bridge will be longer than the existing bridge.
Right. Now, talk to me about the underbridge clearance. I heard you say initially, or at least I thought I heard you say, that that was required, a foot of clearance at storm level elevation.
Right.
Is it required or desired?
Well, the way that the FOMDOT hydraulic and drainage manual is written, they say it's required, but they say the requirement can be waived if it's difficult to meet the criteria, or not difficult, but unreasonable to meet the criteria based on economics and right-of-way and environmental impacts. So if you don't have those, if you don't have a substantial reason why you can't meet that criteria, they will enforce it.
Do we?
You could argue certainly that when you look at the cross sections and you look at the property impacts, I'll go back here on these nearby properties, you're trying to increase profile grade by 5 feet in this area here. And you look at the slopes and how far these slopes come on these properties, what the grade of the driveways become when you are picking up the profile that much. You could certainly argue that you're impacting that property so much that it's not reasonable to provide that underclearance.
Right. Now, if I remember correctly, my bias is circa. We don't use FEMA maps. They're in 2013, and there's a lot of questions about how they were produced in the first place. But if I remember correctly, the 100-year storm, in the 100-year storm, the surface of the existing bridge is pretty near dry.
You're correct. It is, I would say it's just barely dry now.
Right.
Yeah, I think it's, I can open up a better view of that profile here.
It's around 9.2, I think.
Say again, Greg?
It's around 9.2, the existing bridge.
Yeah, so that might be a little low for the 100-year storm.
Yeah, because 100 years, 9.7.
Right.
Yeah, the low point is actually, to that, in front of that house that he was just showing.
Yeah, it looks like it's close. Yeah, certainly within a foot of being dry.
Because of course, in our consideration now, the task force, resiliency task force considerations, we were looking at the wet on either side in 100-year, and talking about raising road elevations all the way along to accommodate the 100-year. But of course, recognizing that, so we got a nice dry road now from beyond the Fisherman Esker Point over to the stop sign going into Groton Long Point. And at that point, you go uphill a little bit into Groton Long Point. It's relatively dry into the pond on the other side in the 100-year flood, as you showed. So the roadway elevations in this area is an interesting one. When you showed me that picture of a 4 or 5 foot elevation, and you showed me blacktop that sort of ended maybe short of the fisherman on the one side, east side. I was thinking about why, extended beyond the cost, of course, extended further east and the same thing further west. But of course, the properties are, particularly on the west side, are certainly a consideration. And I'm sure they'd feel that way.
Okay, Andre, I see you have a question. You want to?
Thank you.
Thanks, Frank.
Yes, thanks, Greg, and it's great to be with you all tonight. Just would like to echo one of Frank's comments regarding the proposed width of the road. I see that the proposed lane width is 12 feet, going both north and southbound. And ideally, you would like to see those roadways be, the size of those roadways reduced to mitigate speeding. And certainly that's a more higher traffic area, especially in the summers, with more pedestrian traffic and cyclists. And so obviously, lanes that, are as wide as 12 feet encourage higher speeds. So I would propose that you consider some of the recommendations made by the Southeastern Connecticut Council of Governments as it relates to bicycle and pedestrian safety. They issued a list of improvements that they would like to make with respect to bicycle and pedestrian safety in the region. And they proposed the Eastern Shoreline Path, which would go through Route 215. And they proposed bike lanes actually that would go through that state road, as well as pass through what would be the bridge. So I would kind of keep that in mind, especially if on the existing plan or the proposed plan, I would propose that we reduce it from 12 feet to 10, and then consider at least a 1 to 2 foot buffer, for that both shoulders going north and southbound, and allow those shoulders to be designated as bicycle lanes. I am very glad to see at least one sidewalk is incorporated in the plan. It's definitely a welcome addition to that bridge. Ideally, obviously, you want to see it done on both sides, but I think at the very least, we can have one that's great. And aside from that, obviously, just being cognizant of the costs. It's going to be a pretty big item, but it's imperative we get it done, because the longer we wait, the more expensive it'll be. And more than anything else, it's a public safety concern. I'm sure, to ensure that in the case we have a very bad hurricane, people in Groton Long Point can get out safely. So that should be of foremost importance. And, again, thanks, Greg, for your leadership on this, and, looking forward to working with the task force.
Okay, thanks, Andre. Just John, I guess John Ives, you can correct me if I'm wrong, but the width of the bridge itself is somewhat dependent on A, federal funding, and B, the demolition of the existing bridge and the construction of the new bridge because of the spacing of the stringers and whatnot. And then, so if the bridge ends up a certain width, we can always put in pavement markings, and we had always intended to have bike lanes on both sides of the bridge anyway. So if they were 4 feet, 5 feet, whatever they end up being, we can paint 10 or 11 foot travel lanes. Is that correct?
That's correct. Yeah.
Okay.
Your travel lane, minimum travel lane width will come right out of the PennDOT highway manual, but you could control you could, I think, answer some of Andre's concerns with striping and still have the width that you need for stage construction when you won't have the bike lane.
Would you say we won't have the bike lanes, or?
Not during stage construction, you won't have bike lanes.
No, I understand. I'm saying when it's all done, we'll have bike lanes on both sides.
You can do that, sure.
Yeah. That was always our intention to do, as well as the sidewalk, at least on the south side.
And And I took that down, Andre's statements there, with SE Cog and other cogs. We've got, our planners have good relationships down there, and have done a lot with bike and peds, and have done some pilot programs, testing speeds with different roadway widths and associated bike lane widths. So we can engage our folks for next time, just to give you some of their thoughts. But we do have bike ped planners in our office that deal with situations like this. But like you said, the funding is going to require minimum widths that DOT is going to want to see.
Okay. I see Michael Knoll has a question.
Yeah, hi, Michael, Noel here. I do also echo Andre's recommendation for the sidewalk. And it'd be nice to have it on the south side, extending all the way to Eastern or East Shore Road there, Groton Long Point. And also had a question about the width of the passage of water under the bridge. If you put the new supports out wider, what did you say, 80 feet? Or isn't it always, weren't we talking at one point about increasing the water flow through there? So wouldn't it be a good idea to remove the old abutments after? Just to make a better flow situation? Just that's all, just a comment.
Well, I can discuss that. This is a plan and elevation of the existing bridge. And this will serve a couple purposes. We can talk about width as we go. But the existing abutments are supported on piles, wood piles. And from abutment to abutment, this is looking down from the sky here. There are, this is kind of a unique situation that I've never seen before. There are these struts that run under the channel. So under the channel, there's a reinforced concrete beam, basically, buried beneath the mud line. And that is also supported on wood piles. So, getting in there, to remove the existing abutment completely is going to be quite a task to get in there. And normally we'd sheet it, use some sheet piling around the whole thing if we were going to remove it completely. And I'm not sure how we would get rid of these, struts. It would certainly be easier to just do a partial demolition and take that wall down, as far as we could.
Yeah, I mean, is it possible to go down at least to the mud line or below the mud line?
We could go down to the mud line.
That would be highly recommended. Not so much from the flow standpoint, because the flow is driven in large part into the basin by the tidal range, and you're down below low water. But from a safety standpoint, GD well, somebody's going to hit that.
Yeah, so I from a constructability standpoint, it's easier if you leave a part of the existing abutments and build behind them. You can use them for water handling. It's cheaper. You can maintain the channel between the existing abutments instead of having to, put some kind of sheeting around them to completely remove them. And also during staging, when you're trying to maintain, one lane of alternating one-way traffic through here, and thinking about, the more you remove of the existing structure on the other side, harder it is to make that happen. So, you know, from a constructability standpoint, I think we'd like to keep more of them there. Like I was saying, you know, cut them off higher up so you can still see them. I know you have that navigation channel, so to speak, beneath here. It's, you know, it's smaller boats that use that.
To what extent is the finished channel width going to be determined by the hydraulic studies you're about to perform, right? Why
Well,
wider? Why wider?
I don't think that there's a hydraulic need for a larger opening. I know that the concern with possibly opening this up before, as is shown in this study as an option, was we were looking at even a 3-span bridge.
Mhm.
There was concern about wanting to flush the cove, so to speak. And I remember at the time there was also kind of a competing concern. I think there were, was it oyster beds in the cove, and some people didn't want it to be flushed. So I know that there are thoughts both ways, and the easiest route is probably to leave it as close as possible to what it is now.
But you're making it wider, right?
Well, we're building the proposed abutments behind existing.
Yes.
It ends up being a
Wider.
small change. It would be a little bit wider.
Mhm.
You're still gonna have some kind of riprap protection in front of them, even if you remove the existing abutments down as far as you possibly can, which would be, I would say, not below the existing footings. And to go back to that question about width, here's the existing bridge. So right now, I believe we have 4-foot lanes and almost 3-foot shoulders. So there was a
30 feet.
small increase in shoulder width on the proposed bridge. I think we were up to 4'6". And then we did have the addition of the sidewalk. So it's 35 foot 2 inches out to out now. And I think on the, let's see, on the typical section that I showed you, which was from this early study,
42.
32'6".
Mhm.
If you incorporate bike lanes, your bike lanes are going to be typically they're recommended to be 5 feet. If you had a 5-foot bike lane, or even let's say a 4-foot bike lane and a 2-foot buffer, and say an 11-foot lane instead of a 12-foot lane, it's 11 and 2 and 4, 17 foot.
Okay.
You got a 34-foot wide roadway. Going to bike lanes is going to put you a little wider. If you didn't have the buffer, or you could stripe it differently, I guess. You could stripe it as a bike lane instead of as a shoulder. Just add the bike markings. There are options there. We can work with you on that. but it's gonna be wider.
So John, did you have that elevation sheet? I think you pulled it up real quick. I saw it there.
It should flick by.
Yeah, this is kind of it. This kind of just shows the elevations and I don't know if you can just maybe talk through and kind of explain what all this is so the task force understands, you know, how high this bridge and causeway could potentially be.
I'm sorry, Greg, before you get on to that, this may be what confused me at the beginning. Existing bridge with 50 feet.
Yeah,
Proposed bridge with 86 feet.
you're gonna have to forgive Jim for that one. He's talking about length.
That's the span. It took me a while, Frank, to figure that out too. It's the width if you're a boater, I guess.
Yeah,
Okay.
I don't know.
Okay.
So yeah, that's not the width. You know, I think without getting too much into the elevations, you know, the most important thing I think is how much profile grade is coming up. That 5 feet. 5 feet is a substantial increase in profile. We're talking about having a wall along the ocean side, the seaward side, and having riprap in front of the wall, and having at least riprap along the causeway on the cove side, and then chasing that grade back into the lawns and the driveways on the adjacent properties. You know, Jim had worked up some early numbers here. He had a low chord clearance of the existing bridge, or a low chord elevation of 5.6 feet, which left you with a clearance above mean high water of 4.7 feet. So your boats at your marina there were either passing under low tide or dropping the windshield to get under there any other time. For the proposed bridge, he was talking about raising the low chord all the way up to 10.5, which is nearly 5 feet. It did give you a much greater clearance under the proposed bridge, which I'm sure the folks at the marina would love. You also have a longer structure, and I think possibly a little deeper than Jim envisioned. So you're up at least 5 feet on the profile, and chasing that back at a 2-to-1 slope, which is barely, you know, you're gonna have a shelf for guide rail, which is generally 4 feet, and then beyond that, chasing that 5-foot profile increase back at least a 2-to-1, so the guy can mow his front lawn there uncomfortably. Puts puts the bottom of the slope at least 15 to 20 feet out from the roadway. I think the driveway grades were very steep. And it should be a consideration. And I think, to show you the full impact, we would have to go and take a closer look at the profile and cross sections and make sure that they're, let's say, get another set of eyes on them and make sure that they're right. But I think we're chasing grade back all the way to some front door steps there and to some garages on the approach.
Yeah, these are the first two houses on the north side as you come into Groton Long Point. They are, those two there, they're going to be really impacted by this elevation change. So I think it'd be helpful if you could, maybe give some cross sections or some, some simple type of illustrations to show the task force, what's going to really happen there if we raise this causeway up to 11.3 feet.
Yeah, I have seen some early, an early cut at that, Greg, from Jim, but I want to take a closer look at it. But even, I'm not sure that the profile comes up far enough to incorporate the structure depth that we need. And I'd like to look at it a little bit closer before we present it.
Yeah, I think it's just those first two on the right, on the north side there as you come over the bridge. I think the rest of them was fairly minor grading.
Right.
Remember right.
But of course, those two houses in the 100-year flood
They're
are going to
probably
be underwater.
underwater, exactly.
So they might also be thinking about raising house elevation at some point in all this. Can we drop back to that slide you had with the text on it? I'm not clear on a couple of things. That guy. The low chord.
Bottom of bridge.
The bottom, that's when I go under the bridge, it's when I hit my head on, right? Okay. So where did you decide that you needed clearance at mean high water of 9.6 feet?
I think when Jim worked this up, he was looking at that 100-year still water elevation of 9.7.
No, I'm not, hang on. We're not there yet.
Yeah.
What I understand is under normal circumstances, I got an average high tide level. I'm going to have 9.6 feet. If my feet are in the water, just in the water, I got 9.6 feet up. My head isn't my 6'4" head is not hitting the bridge, right?
So I'm just explaining how Jim got there. That's under a high tide situation and not under a flood situation.
Exactly. Mean high water.
Yeah.
Where did 9.6 come from? The size of a boat?
No. So the 9.6 wasn't a design criteria. The criteria was being 1 foot above the 100-year flood elevation, which I'm not sure why he had 10.5 if the 100-year still water elevation was 9.7. Low chord should have been 10.7. But
I hope you can understand why I'm confused.
So, all right, he wanted to be 1 foot above the 100-year flood,
which gave me a clearance. Of 9.6.
Yeah, if I say
average
foot above 100-year flood, then I'm going to be this 9 point. He came up with 9.6 feet above high tide, normal high tide.
I got you.
So.
Okay. So I suppose number one, if we drop the bridge down, I let it get wet in the 100-year flood.
Yeah.
Which this bridge does right now.
Right.
And has. We go back to the original question about if we don't care, DOT doesn't care? Or we have to give them a good reason why.
But
The reason why would be the elevation. Huh?
we're working for you and we'll support whatever you decide. If it was my bridge and my money, I would say I want the causeway and the bridge to be, I want the roadway surface to be dry, considering the rise in sea level elevation.
Right.
So at a future date down the road, say 100 years from now, when someone is living on Groton Long Point and there is a flood, they want to be able to get out of there and see the roadway when they leave.
Yeah.
We don't want the causeway to be underwater. But I don't care if the girders get wet once every 100 years. What does that matter? So that's from my perspective as a bridge engineer, not as a hydraulic
Yeah.
engineer.
Well, just to make us all go a little grayer or bolder, as the case may be, the a number of folks are talking about the 500-year storm as a design criteria because of the increase in frequency associated with climate change. So realize that this 20 inches is to 2050,
Yes,
and that once we get beyond 2050, we go to 2100, the spread in the curves, different models, gets much greater.
right.
And there's very little agreement what goes on beyond 2050 or so. So we'll keep it at 20. We're designing out to 2050 and with from sea level standpoint and longer from a structural standpoint.
Yes.
I guess, Greg, if we had to sit and guess about it, lowering the bridge a bit, allowing the bottom to get wet during the extreme event, with the roadway remaining reasonably dry in the extreme event, is seems pretty reasonable. And the argument would be that if we went up to give you a clearance of a foot at the extreme event, that there'd be such a hump in the current bridge structure and the resulting bridge structure to give us problems right and left of it, and the cost of the causeway that goes along with it. Sounds like.
Yeah, I mean, these are all the things you have to balance out, is the costs and all that. Now, does the funding, does kind of drive any of this as well, John? I mean, the federal funding?
So the feds will rely on PondDOT to administer the project and for to make decisions about waivers of design criteria that would apply to design speed, that would apply to meeting your drainage manual criteria. You'll still be able to get funding if you don't meet that 1 foot of underclearance, because we decide that the right-of-way impacts are too high and that the cost is too high. So, you'd have, we could give you some cross sections that I think would support that.
Okay.
And probably some rough costs. Costs of wall, your additional wall, your additional height of abutments, your additional causeway construction. You have the difficulty of staging your alternating one-way traffic while having a 5-foot difference in elevation between the existing road and the proposed road. So.
See, Andre, you have a question?
Yes. Do we have a deadline as to when we need to determine the elevation of the road?
Well, I think that the schedule that we had set up, I'll go back to that. I don't want to put you on the spot, Greg, but in your discussions with Jim, I think that this referendum process, you must have decided, took a certain amount of time.
Mm-hmm.
and probably worked back to this May.
Yeah,
Maybe,
if we do a referendum in November 21, we need to start the process through, all the town clerk and the bonding attorney and everything else in May of 21 to give us enough time to be on the ballot in 21. So that's where that May date comes from.
so before that May date, you need to have some better handle on the costs.
Yeah, we need to get a definite cost of the project.
So for that, we need to go through the design process and I can't really assign a deadline, but I think, the sooner the better. That decision on the profile of the causeway can't come soon enough for us.
Yeah, I think that's why, we wanted to discuss that topic mainly tonight, and then probably, the next meeting, just to kind of, so we can give our design team, something to design to meet the schedule.
So could we, I think a good plan would be to come back next month with some cross sections that would show you the property impacts. And let us take a closer look at the profile and make sure that we're sound from an engineering standpoint.
Okay.
From one last question, the other thing that comes to mind, is there any consideration for the differences in structural loading that might result if we were to bring the bridge down so that it is more likely to be subject to wave attack in the extreme event? Do you make it, and if so, I'm sure that might impact, I could conceive of bridge construction that was more sensitive to being hit by waves and less sensitive being hit by waves. It must affect the overall cost of the operation. Any consideration for loading effects on this?
The structure type that we're looking at for this clear span over the existing abutments it's called an integral abutment structure. I don't want to get too technical on you, but the beams that support the bridge deck are tied right into the abutments.
Right.
So rather, your existing bridge, which is very heavy because you have those concrete encased girders, but it's supported on bearings, and so there's kind of a joint there that the superstructure is connected to the substructure at that location.
Mm-hmm.
What we're looking at for the proposed bridge with these integral abutments is there's much greater connectivity all from the superstructure all the way down to the piles.
Right.
No, it doesn't have the bearings there, and there's reinforced concrete that continues from the deck all the way down to the piles. So there really wouldn't be an increased cost for that reason.
Yes, you figure it's strong enough to handle anything that way, right?
Right.
Keeping in mind that the existing bridge did.
Yeah. Probably by gravity. The thing is really heavy.
Right.
So
That's it. Something to be said for that. Thank you.
you're welcome.
All right, anybody else have any other questions? Comments?
Try to remove those existing supports to the extent possible. It says right here on the pad.
I would
As soon
agree,
as-
Frank.
Make a note of it.
Yeah,
As soon as this recording's done and available publicly, I'll send that to the members who missed today so they can get up to speed.
Yeah, oh, yeah, thanks, John. I wanted to ask John Hapowitz, because we had talked last time about, getting the website back up and active and getting, some of this stuff out on the website. Is that, I know you're going to look into that. Is that still ongoing?
Yes, I reached out. I will reach out again first thing tomorrow to check the status.
Okay, thanks.
You're welcome. Thank you. And John Ives, that's Kevin Tedesco.
Got it.
Was doing that.
Okay, Michael, you have a question? See your hand up.
Oh, yeah. So just wanted to get clear. So for next month, you're going to have basically pictures showing the grading and how it relates to the current properties. Is that right?
Yes, I think that's what you need to see to make, to make your decision here.
Yeah. Okay. All right. Thank you.
You're welcome.
All right, anybody else? Any other questions? No? Well,
Thank you.
thank everybody for coming, attending tonight. Hope everybody has a good holiday, and we will see you next month.
Thank you, you too. And if anybody has any questions in the meantime before the next meeting, please reach out.
Yeah, you can feel free to email me.
Good.
And to incorporate those into our next meeting.
Thanks very much. Stay well, folks.
Thank you.
Thanks.
Thanks.
Thank you. Happy holidays.